Good afternoon to all of you. Myself, Dr. Jagannatha Samanta. Our R&D project, design and development of smart IoT-based air quality detection and monitoring devices for Industry 4.0. So we have received a grant of 22,000 from the Institute of Engineers. Thanks for providing this grant. And we have developed this project, and we have done a prototype. So myself, Dr. Jagannatha Samanta, and my colleague, Mr. Topon Maiti, we take the initiation, and we are working with two students named Mrs. Deblina Chakraborty and fourth year student, final year student, and Mr. Roningwal Roy Chaudhary is the third year student. So they have worked this project. So I will request Deblina to start the presentation.
My name is Jagannatha Samanta and I am a final year student of Electronics and Communication Engineering. So moving forward, I will discuss the parts about the contents where this includes introduction, literature review, the discussion about the AQMS and the proposed work and the implementation, and then the conclusion and future work and with the reference. So coming to the introduction, so basically the main motto was to detect the pollutants that are polluting the air in the industrial area, as this is a industrial 4.0. So we are majorly focusing on those pollutants. Those are creating the most of the pollutions in these specific industrial areas. So for that we have basically used some of the previous year's data, and also we have done one literature review. On that, I have already mentioned the different studies that are made on different years, and highlighting the implementation for air quality management strategies to protect the public health. And from here, after seeing this review, I have come to a conclusion where I have actually created this structures where we will use some specific sensors, just like MQ135. MQ135, that is for carbon dioxide, MQ6, that is for methane, Yeast11 for humidity and temperature, and MQ131 for ozone, and MQ136 for hydrogen sulfide. These are the main gases that we are focusing on, and after that, after measuring this data from these sensors, what we have done is that we have transferred it to a node MCU called ADMEGA 328P, and from there we have uploaded all the data to the Wing console, and after the analyzation, we have actually shown that what are the details that we got from here. So if you can see that it is measuring as it is already connected, and this is the data that it is providing right now. So as you can see, the data are here. And this is AQI, which means that this thing has calculated all the various parameters, and depending on that, it is giving us a air quality index if it's good or not.
I am Roningwal Roy Chaudhary, student of third year from Electronics and Communication Department. So now we are moving to the analysis part. Here in the industry, there are various harmful gases, and we have seen them in the parameters as described by Devolginadi. So now, why we are using ML? So in the industry, when there are various toxic gases, so if we train them using the ML model, so we can, and if they go beyond a certain level, then we can get an alert issue. And we have used various ML models like SVM, random forest, linear regression, but among them, random forest is the best method as of now, giving the best precision. So here, so random forest is basically a bunch of decision trees, and it after processing, it gives the data based on the process of majority voting. So in terms of that, we are getting a higher accuracy rate than others. So it's some reason that we are choosing random. So as we can see, using the random forest model, we are getting an overall accuracy of 0.94666 and continuing, which is nearly 94.6%.
So that's why we considered that the random forest model is the best model that can give us the best accuracy in for our project.